Functions of several variables and partial derivatives. If we are given a function f that is defined by f of x equal to 3x raised to 2 minus 5x plus 1, this is a function that involves a single variable x. No? So f is a function of a single variable x. A function may also involve several variables. Say for example, f of xy equal to x squared y squared minus x over y. The function f is defined by two variables x and y. You may also write this function as c equal to x squared y squared minus x over y. So for f defined by x squared y squared minus x all over y, you can also get its function value, say for example f of 1 1/2. What you do is you simply substitute 1 to x and 1/2 to y, and you will be getting 1 squared 1/2 squared minus 1 all over 1/2. So that will be equal to 1/4 minus 2 or negative 7 over 4. So you can write f of 1 1/2 equal to negative 7 over 4. So negative 7 over 4 is the function value of f when x is equal to 1 and y equal to 1/2. Now, how do we get the derivative of a function involving two or more variables? So we apply partial differentiation. So let me illustrate the process. So supposing that your function f in terms of x and y is defined by 4x cubed y squared minus 2x plus y. The derivative of f with respect to x is denoted by partial derivative of f with respect to x, right? So please take note of the notation for the partial derivative. So we call this as the partial derivative of f with respect to x. What we do is we apply the fundamental differentiation formulas, bearing in mind that we are differentiating the variable x and all other variables other than x will be treated as constant. So I repeat, if you want to find the partial derivative of the function f with respect to x, you apply the basic differentiation formulas by differentiating the x variable, and all other variables other than x will be treated as constant. So for the first term, 4x cubed y squared, since we are differentiating with respect to x, we treat y squared as a constant. So the constant in here for the first term is 4y squared, and we are differentiating x cubed. And we know that the derivative of x cubed is 3x squared. So what we write is 4y squared times 3x squared. 4y squared treated as constant, we differentiate x cubed equal to 3x squared. Alright, and then for the second term, negative 2x, the derivative of negative 2x is negative 2. And the last term is y. There is no x involved, so y is a constant. And we know that the derivative of a constant is 0. Alright? So your answer here will be 4 times 3, that will be 12, x squared, y squared minus 2. How about the partial derivative of f with respect to y? Now, we are differentiating all y terms and x terms. The x terms that you would find in the function will be treated as constant. So, for x cubed y squared, we are differentiating with respect to y. So, we differentiate y squared, and we know that the derivative of y squared is 2y. Alright, so what we write is 4x cubed, that is actually a constant, and then the derivative of y squared is 2y, minus 2x. There is no y term involved, so the entire 2x is treated as a constant whose derivative is 0. And then plus y, the derivative of y with respect to y is 1. So final answer here is 4 times 2, 8x cubed y plus 1. We also have higher order partial derivatives. No? Higher order partial derivatives. So we want to find the second partial derivative of f with respect to x. So what we do is we simply take the partial derivative of the partial derivative of f with respect to x with respect to x. So we take the partial derivative of, our answer a while ago is 12x squared y squared minus 2. So we take its partial derivative with respect to x. So again, since we are differentiating with respect to x, we treat y squared as a constant. The derivative of x squared is 2x. So 2x, the derivative of x squared is 2x. So we multiply 12y squared by 2x. And that will be 24xy squared minus 2. The derivative of 2 of your constant is 0. Okay. How about the second partial? The second partial of f with respect to y. The second partial of f with respect to y. That is equal to the partial derivative of the partial derivative of f with respect to y with respect to y, or the partial of 8x cubed y plus 1 with respect to y. So differentiating y, the derivative is 1 times 8x cubed. And then the derivative of the constant 1 with respect to y is 0. So that is our answer for the second partial of f with respect to y. We can also determine the partial of f, second partial of f with respect to y with respect to x. So this is equivalent to finding the partial of f with respect to x with respect to y. So we take the partial of f with respect to x is 12x squared y squared minus 2. Now we take its partial derivative with respect to y. So that will give us the derivative of y squared is 2y. So we multiply it to 12x squared, and that will be 24x squared y. And the partial derivative of 2 with respect to y will be 0. How about the partial of the second partial of f with respect to x with respect to y? So that will be the partial of f with respect to y, then with respect to x. The partial derivative of f with respect to y is 8x cubed y plus 1. Now we take its partial derivative with respect to x. So the derivative of x cubed is 3x squared. Multiplied to 8y, that will be 24x squared y. And the partial of derivative of 1 with respect to x is 0. So at this point, what do we observe? We observe that the second partial of f with respect to y with respect to x, and the second partial of f with respect to x with respect to y are equal. So we see that the two are equal. So in this case, it only shows that the order of partial differentiation does not matter. So that means that the second partial of f with respect to y with respect to x is the same as the second partial of f with respect to x with respect to y. Okay, there are other notations for partial derivatives. The second partial of f with respect to y with respect to x is written as f sub x and then y. Alright, so you start getting the partial derivative of x, then followed by y. Similarly, the second partial of f with respect to x will be f of x. Likewise, the second partial of f with respect to y can be written as fy. So we take note of these other notations for partial derivatives. So we take on some more examples. Say we're given z equal to the square root of x squared plus y squared minus 3x y squared plus 4. So we find the partial of c with respect to x, the partial of c with respect to y. Then let us also get the second partial of c with respect to x, the second partial of c with respect to y, and the second partial of c with respect to y with respect to x. Alright? So first, the partial of c with respect to x. For the first term, we apply the generalized power formula. That is x squared plus y squared raised to 1/2. So that will be 1/2 x squared plus y squared raised to 1/2 minus 1, negative 1/2. And then the derivative of x squared is 2x. Of y squared, that will be 0. Minus 3xy squared. The derivative of x is 1 times negative 3y squared, or negative 3y squared. And then the derivative of 4 is 0. So we can cancel the 2. What we get is x all over. We bring down the negative exponent down below. That is equivalent to a radical square root of x squared plus y squared minus 3y. For letter B, we take on the partial derivative of c with respect to y. That will be equal to, again, we apply the generalized power formula to x squared plus y squared raised to 1/2. And that will give me 1/2 x squared plus y squared raised to 1/2 minus 1 is negative 1/2 times the derivative of x squared with respect to y is 0, and the derivative of y squared with respect to y is 2y, minus derivative of y squared is 2y. Alright? So multiply to negative 3x, that will be negative 6xy. Plus derivative of 4, 0. Final answer here will be y all over the square root of x squared plus y squared minus 6xy. Next, the second partial of z with respect to x. So we just take the partial derivative of c with respect to x, which is x. Let me write this as x, and then x squared plus y squared to the negative 1/2 there, minus 3y with respect to x. So second partial of c with respect to x, we take the partial of c with respect to x with respect to x. Okay, for the first term, it involves a product, no? X and x squared plus y squared to the negative 1/2. So we apply here the product rule. Derivative of x is 1, and then x squared plus y squared to the negative 1/2. Plus x, we now take on the derivative of x squared plus y squared to the negative 1/2, which is negative 1/2. And x squared plus y squared, negative 1/2 minus 1 is negative 3/2. Alright, times the derivative of x squared plus y squared with respect to x, which is 2x. Then, derivative of negative 3y with respect to x is 0. So, we just simplify this. We can factor what? We can factor x squared plus y squared to the negative 3/2. So factoring x squared plus y squared to the negative 3/2 from x squared plus y squared negative 1/2. No? So that is actually subtracting negative 3/2 from negative 1/2. So negative 1/2 minus negative 3/2, that will be positive 2/2 or 1, or x squared plus y squared. And then minus, alright, we have factored x squared plus y squared to the negative 3/2, leaving x squared. Alright, so what do we have now? I think x squared will cancel. So what we have is y squared all over x squared plus y squared to the 3/2. There. Next, we take on letter D, the second partial of c with respect to y. So that will be the partial of y over square root of x squared plus y squared. I might as well use the other one. Partial of y square root of, or rather, sorry, y times x squared plus y squared to the negative 1/2 there, minus 6xy with respect to y there. So just like what we did earlier, now we apply the product rule for the first term, y times x squared plus y squared to the negative 1/2. So and we are differentiating with respect to y. No? So the derivative of y is 1 times x squared plus y squared to the negative 1/2 plus y times the derivative of x squared plus y squared to the negative 1/2 with respect to y is negative 1/2 x squared plus y squared, negative 1/2 minus 1 is negative 3/2 times, of course, the derivative of x squared plus y squared with respect to y, which is 2y. Derivative of x squared with respect to y is 0, and for y squared it will be 2y. Then minus the derivative of negative 6xy with respect to y is negative 6x. So just like what we did earlier, we factor x squared plus y squared to the negative 3/2. So that becomes x squared plus y squared. Negative 1/2 minus 3/2 is 1. So that will be x squared plus y squared raised to 1. And then negative and negative, that will be positive. Y times x is xy squared. Alright? That is xy squared. This is now equivalent to, what can we factor here? Okay, there's nothing to factor. So x squared plus xy squared plus y squared all over x squared plus y squared to the 3 halves. Okay, then finally we determine, letter E, the second partial of c with respect to y with respect to x. So it's the partial of x squared plus y squared to the negative 1/2 minus 3y now with respect to y. So we apply again the product rule for the first term. Now we are differentiating with respect to y. So, since we are differentiating with respect to y and x is treated as a constant, so we are not applying anymore the product rule here because x is a constant. We just apply it to x squared plus y squared negative 1/2. So x is a constant. And the derivative of x squared plus y squared to the negative 1/2 is negative 1/2 x squared plus y squared to the negative 1/2 minus 1 negative 3/2 times the derivative of x squared plus y squared with respect to y, which is 2y. Then minus the derivative of 3y, which is negative 3. So we can cancel the 2, and then x times y all over x squared plus y squared to the 3/2 minus 3. Right? So I have here several exercises that you can work on. We determine the indicated partial derivatives. So f of xy equal to sine of xy minus 3y squared. We determine the partial of f with respect to x, partial of f with respect to y, second partial of f with respect to x, second partial of f with respect to y, second partial of f with respect to y with respect to x. Number 2, say we have g of xy equal to ln of x squared plus y squared minus square root of x minus y. So partial of g with respect to x, partial of g with respect to y, second partial of g with respect to x, second partial of g with respect to y, second partial of g with respect to y with respect to x. Finally, say we have h of xy equal to x over y minus, let me see, arctangent of x over y. So partial of h with respect to x, partial of h with respect to y. Okay. So how about the differential? How do we find the differential of a function of several variables? Say we have f of xy equal to 7x squared minus 3xy plus y squared. The differential of f is defined as the partial of f with respect to x times dx plus the partial of f with respect to y times dy. So since f is a function of two variables x and y, the differential of f will involve the differential of x and the differential of y. So we just get the partial derivative of f with respect to x and multiply it by dx. Get the partial of f with respect to y and then multiply it by dy. So we apply this formula for the given function f. But first, we need to find the partial of f with respect to x. So 7x squared, that will be 14x. For negative 3xy with respect to x, that will be negative 3y. And for y squared, that will be 0. Now, the partial of f with respect to y is equal to, we now get the derivative of each term with respect to y. For 7x squared, that will be 0. For negative 3xy with respect to y, that will be negative 3x. And for y squared, that will be 2y. So, the differential of f is equal to the partial of f with respect to x, which is 14x minus 3y quantity dx. And partial of f with respect to y is negative 3x plus 2y times the differential dy. So we may rewrite this as df equal to 14x minus 3y dx minus 3x minus 2y dy. Okay? So, for the given set of functions with partial derivatives, you also get the differential of f, differential of g, and the differential of h. Okay? Thank you for listening.